Okay, guys, this is Unit 4. Unit 4 was a lot about inverse trig functions, so it's the process of going backwards. We're used to evaluating sine, cosine, or tangent of an angle, but now it's when we're going to go backwards. So I'm going to start with like a fraction and a ratio. I need to figure out what my angle is. You'll notice that we're doing principal values here. Just as a quick little reminder, if I'm using sine, or I guess I should use sine inverse for principal values. I use the first quadrant for positives, the fourth quadrant for negatives, and my principal values or my angles will be between pi over 2 and negative pi over 2. For cosine inverse, I use the first and the second quadrant, and I go from 0 to pi. And for tangent inverse, it's actually the same as sine. My positive answers are here, my negative answers are here, and I go from negative pi over 2 to pi over 2. So remember, when I use principal values, I should only have one answer because I'm restricted to one positive and one negative quadrant. So here's what's happening. This is saying, when does sine have a value of negative root 3 over 2? So the first thing is I notice that it's negative, so it's going to be in the fourth quadrant. Sine has a value of root 3 over 2 at pi over 3. I gotta make sure I'm getting this right. At pi over 3, we're going to be in this quadrant, so my principal value is going to be negative pi over 3. We're not going to use 5 pi over 3 for principal values. Remember, the answers have to be between negative pi over 2 and pi over 2, so when I'm using sine and tangent, it's just going to be your reference angle negative. Let's do this next one. Arc sine of negative 1/2. Sine is negative in the fourth quadrant, so I'm in the fourth quadrant. Sine is 1/2 at the reference angle of pi over 6. And then because it's in the fourth quadrant, we're going to call it negative pi over 6. Okay? This is asking when cosine is 0. One of the things you might want to think about is just make a, I'll do this in red. Remember, our coordinates here are over 1 up 0, over 0 up 1, and then here this would be backwards 1 up 0, and this would be over 0 down 1. Well, for cosine for principal values, I'm looking up here, and I'm looking for when cosine is 0. Cosine is 0 when the x-coordinate is 0. The x-coordinate is 0 here, so my answer is pi over 2. Okay, it's going to be a little more complicated now. There's some pieces. Remember, we have some methods. I see these composites, so you have tan of arc something, or you have like secant of arc something. Start by looking to see if any of them match. And I notice here I have cosine inverse of cosine. If you just see the same thing of it, like one's the inverse of the same trig function, the answer is just going to be what's here. The answer is 1/5. That's what I would look for first. The second thing I would look for is reciprocal, or you would look for inverse function. Okay, secant and cosine are reciprocal. Sorry, not inverse. They're reciprocals. Secant is the reciprocal of cosine. When that's the case, we take the answer and we just flip it. We take the reciprocal of it. Okay. I don't think anything else here helps me with that. So now what I would recommend doing is look for unit circle values. So for instance, I know sine with 1/2 is a good example. Sorry, here's another reciprocal, cosecant and sine. My answer here is just 2. If you see reciprocals, our answer is just going to be the reciprocal of what we have. Okay, so actually we'll just start at number 4. So when I look at this, I see arc sine of 1/3. 1/3 is not something that's in my reference angle chart, so I'm going to have to draw a picture. Notice that we're doing, where sine is positive. So with principal values, that means I have to be in the first quadrant since it's positive, so I'm going to draw a picture. Sine is opposite over hypotenuse. If I do the Pythagorean theorem, just for the sake of time, I'm not going to. You can do it. You should get root 8. So theta. Okay? So the answer to an inverse trig thing is going to be an angle. So we're saying that theta is the angle where this is true, because sine of theta is going to be 1/3. So I'm now asking, what is tangent of this angle that I've now created, or this picture I've now created? Well, tangent for this picture is going to be opposite over, sorry, adjacent. So this is your answer. Remember, arc is going to ask for an angle. So we created the angle for which this was true, and then we're going to do tangent of that angle. So that helps you remember the answer to an arc problem is going to be an angle, and then we're doing tangent of that angle. Let's do another one. Okay, here we actually have a unit circle value. So I need to start by asking, where is sine 1/2? Well, sine is 1/2 at pi over 6. But you'll notice we're going to be in the fourth quadrant because it's negative, so my answer is going to be negative pi over 6. So this question is really asking, what is tangent of a reference angle of pi over 6 in quadrant 4? Okay, well, I know in quadrant 4 tangent is going to be negative, and I know that tangent of pi over 6 is root 3 over 3. Okay, here's another one. This is asking, when or at what angle does tangent have a value of 1? Well, this is positive in the first quadrant. Tangent has a value of 1 with a reference angle of pi over 4. So now I'm going to say, what is sine of pi over 4? Sine of pi over 4 is root 2 over 2. Okay, so this is just evaluating. You're going to have to just evaluate simple, more inverse ones here where you're just using your reference angle chart, and these are going to be more complex. These are called composite ones. So now let's go down to solving. Okay, now we're not using principal values. Notice it says now it solves for every answer on the unit circle. So we're going to say, like, when are all of the places that this is true on the unit circle? So notice when we have one trig function, this is on your notes page, we're going to isolate it, and you'll notice that sine of theta is already isolated. So this is just asking the question, on the unit circle, when is sine have a value of a negative half? Well, sine is a half at a reference angle of pi over 6. And it's negative in the third and fourth quadrant. Okay? So the pi over 6 in the third quadrant, that's the one more quadrant. So that's going to be 7 pi over 6. The fourth quadrant is the double minus 1. That's your 11 pi over 6. Those are your answers. Okay, here's another place where we have one trig function. It's isolated already. It's tangent, saying when is tangent 1? Well, tangent is 1 as a reference angle of pi over 4. And tangent is positive in the first and the third quadrant. So my answers to this are going to be pi over 4. In the third quadrant, it's 1 more, so it's going to be 5 pi over 4. Oops. Okay. Number 12 still only has one trig function. It's not isolated yet. I just need to divide by 2. So now I'm saying, when is this a true statement? So you'll notice that so when is cosine root 3 over 2? It's at a reference angle of pi over 6. Cosine is positive, and cosine is positive in the first and the fourth quadrants. So pi over 6 in the first quadrant is pi over 6. The reference angle with pi over 6 in the fourth quadrant is when we double minus 1. So I multiplied 6 by 2. I got 12, and I subtracted 1 for 11. Again, for 13, I only have one trig, but it's not isolated yet. I need to add 1 to the other side. Also, guys, while I'm going through this, I'm purposely doing almost all of the questions just so you guys can see them. But please, once you're getting the hang of things, do them yourself first. Don't watch me do all of them. You can use it to check. But this is really meant for you for when you're stuck, not to necessarily just do this all without trying it yourself. So just as a heads up as you're going through. I want to know when sine has a value of 1. I'm going to flip this over real fast to this chart I made. Sine is 1 when the y-coordinate is 1. So the only place the y-coordinate 1 is here at the top. It's negative 1 at the bottom. That's at pi over 2. Okay, we still only have one trig thing. Let's isolate it. This looks like a small problem to me because this isn't something I recognize. I know I've been pretty lax on you guys with rationalizing radicals, things in the denominator, but this is a case where you really need to, so you can actually recognize what's going on. That's going to give me a negative root 2 over 2. That is something I should know. Cosine has a value of root 2 over 2 at a reference angle of pi over 4. Now we're looking at quadrants. Cosine is negative in the second and third quadrant. So that's the one less and the one more quadrant. So 1 less than 4 is 3. 1 more than 4 is 5. Okay. Sorry guys, I'm going to drink real fast. Okay. Isolate secant. Okay. Secant of theta is negative root 2. We don't have secant in our reference angle chart, so I'm going to turn this into cosine. And the way I do this is by taking the reciprocal of both sides, right? So if I want to turn this into cosine, I'll show you this. Yeah, so I'll just do it like this. If I want to turn this into cosine, it's the reciprocal. So since I turned this into the reciprocal, I have to flip it to its reciprocal. So notice these are reciprocals. Flipped. This is the same thing as 1 over cosine. So to get 1 over cosine of this, I had to flip it. So I also had to flip this. I need to rationalize this so I recognize this. We just did this a moment ago. I didn't mean these to be so similar. So this problem is actually asking the exact same thing as this problem, because it's saying what is cosine negative root 2 over 2. Well, we just did that. I didn't mean them to be so similar. Okay, number 16. Things are finally getting a little bit more exciting. Oh, this is funny. Okay, I'm going to get the 1 on the other side. I am going to divide by 2. And the last thing I'm going to do is take the square root. Now remember, when I take the square root, I'm going to get a plus or minus square root of 1 over square root of 2. So really what I have is cosine of theta equals plus or minus. Wait a minute, you should recognize this. We've just seen this a lot. If I rationalize it, that's going to end up as root 2 over 2. So here's the big difference between 14 and 15. I was giggling a minute ago because the numbers are so similar. You'll notice that the big difference here is now it's plus or minus. I want all of the places where it's either a positive root 2 over 2 or a negative. So my reference angle, I'm going to start doing this in red. My reference angle for cosine to get root 2 over 2 is pi over 4. But now that I want it positive or negative, it doesn't matter which of the 4 quadrants. I need all 4 of them. So this is going to be true at pi over 4. Ooh, let me write my answers up here. Pi over 4. Second quadrant, 3 pi over 4. Third quadrant, 5 pi over 4. And fourth quadrant, 7 pi over 4. So when I take the square root, I need that plus or minus. That's going to give me more answers. Okay. This looks special. Let's come back to 17 in a minute. I want to build up to that. Let's actually jump down to number 19 real fast. Number 19 looks pretty gross, but it's actually not that bad. Here's why. What does that have a value of? For Pythagorean identity, right? So sine squared plus cosine squared has a value of 1. Oops, sorry, that's supposed to be an x. We'll change that to a theta to be consistent with the page. Equals 0. Okay, so it's saying when does cosine have a value of negative 1? Negative 1s and 0s, or 1s and 0s happen on my quadrantal, so I'm looking for when the x-coordinate is negative 1, the x-coordinate is negative 1 at pi. Okay, I actually want to do number 18 next. We're going to go backwards for the last couple. I have sine of 2 theta. As soon as I see this, my double angle formula, I need to change that into 2 sine of theta cosine theta. Okay. I have multiple trig functions, so now I need to factor. I notice I have a cosine theta in both of these. Take out cosine theta, that gives me 2 sine theta minus 1. Because I have these factors, I now need to solve this as two separate problems. I'm going to start with this. And then I'll do this one. Okay? This is just saying when is cosine equal to 0? Well, if I look at the chart we looked at in the front, the quadrantals, cosine is 0 at pi over 2 and 3 pi over 2. We actually have to solve this one. This is saying when does sine of theta have a value of 1/2? Sine of theta is 1/2 at the pi over 6's, and sine is positive in the first and the second quadrant. So we have 4 answers because we have to do the 2 pieces. Okay, here's our most complex one. I'm trying to think if there's a good shortcut for this one, but I think we're kind of stuck doing this out a long way. So the first thing I notice is that I have sines and cosines, and that's a problem. I want to try to turn all of this into just cosine, and it's easiest to do it to cosine because it's the squareds I have Pythagorean identities for it. I don't have any way to change this. So if I rewrite my Pythagorean identity, I know that sine squared is the same thing as 1 minus cosine squared theta. Just rewriting my Pythagorean identity. It's going to give me 2 minus 2 cosine squared theta minus cosine theta equals 1. I'm going to have to factor this. It's not going to be pretty. I want to get everything on one side, and I do not like having a leading coefficient. This is my square term that's negative, so I'm going to move everything to this side. So if I move that over, I get a positive 2 cosine squared theta. I'm going to move that over to give me a positive cosine theta, and I'm going to subtract the 2. That's going to give me a negative 1. Now, this looks gross to factor, so I'm going to remember this is like x. This is like x. So really what I'm factoring is 2x squared plus x minus 1. That, in my mind, is a little bit easier to wrap my mind around. I know if I factor this, I have to have a 2x and an x. And I know I'm going to have a positive 1 and a negative 1. So it's going to be 1 and 1. I know that much. That's the only way I can multiply to 1. This needs to be positive, so I'm going to do this 2x times the 1 is going to need to be the positive 1. This is going to be the negative 1. So if I FOIL this out, that's going to be 2x squared. This is going to be a plus 2x and a minus x to give me 1x, and that will give me a negative 1. So what I really have here, remember x is cosine, is 2 cosine theta minus 1. That came from here. Instead of x, I put cosine. And a cosine of theta plus 1. You just solve these separately. This is asking when is this 0, when is this 0. Math in my head just because I'm running out of space. If I solve this to isolate cosine, remember I want to know when this equals 0. I'm going to add 1 and then divide. I want to know when cosine is 1/2. Here I'm just going to subtract the 1 onto the other side. So I want to know when cosine is negative 1. Remember I want to know when each of these things are 0. That's why we get everything on one side. So let's see if we can answer this question. Cosine is 1/2 at the pi over 3's. And cosine is positive in the first quadrant and the fourth quadrant. Cosine has a value of negative 1 at pi. So those are my answers. Okay.